Hi everyone, welcome back to the channel. I'm the GCSE science teacher. In today's video, we're going to be talking about Hooke's law, and this is part of the curriculum, which is also linked to a required practical. So if you do enjoy this video, please do give it a big thumbs up, share this with someone else, and also subscribe. Thank you so much to everyone who already has subscribed. It's lovely to see lots of you joining this community. So let's get into it, and I hope you enjoy. So the first thing we need to talk about when we talk about Hooke's law and anything to do with this topic, we need to understand the terminology, because there's a couple of words that actually can often get misconstrued as meaning something else. So the first one is actually the word deformation, and deformation just means a change in shape. And there's actually two types of deformation. We have elastic deformation, which means when a force is applied to an object, the object changes shape, but once that force has been removed, the object's shape returns to its original form. So the word elastic means that it has the ability to change but go back to its original place. In the case of inelastic deformation, this is when a force is applied to an object, but actually, once that force is removed, the object never goes back to its original place. And deformation, in this sense, is irreversible. So we can talk about this word when we talk about Hooke's law, in the fact that some objects, like springs, are very elastic, but actually there comes a point where they no longer will go back to their original shape. If you've ever done this experiment, if you were to stretch a spring out, you'll see that actually with extended force, the spring won't be able to go back to its original position. And we're going to talk about how this looks on a graphical representation on a graph, and that will link nicely to the practical as well. So just a bit of key vocab for you to understand here. So Hooke's law essentially can be represented as an equation, which is force, which is measured in newtons, is equal to the spring constant K, which is measured in newtons per meter, times by the extension in meters. Now, a bit of key vocabulary again. The word extension is a length, but it's the length that's occurred after the force has been applied. If you think about a spring, if you were to measure the length of the original spring and then stretch it when you apply a force, the extension is how much further it has grown, how much more of it there is when you've stretched it. So just be careful if you are given initial quantities of the length, or you have to work out extension. There have been past paper questions where they ask you to read off a measuring ruler or something like this. So just be careful you know what the word extension actually means. It's just how much further it has increased in length. So here's some examples. And again, with any calculations in science, if you type it, you must write it. I'm kind of always saying this, I feel, but it's so true. If you type in your calculator in the exam, don't forget to write it down. Please make sure you write your units and you write out the equation as well. You are given a lot of equations in GCSE exams, but just be careful that you are showing you're working out really, really nice and neatly, and it makes sense so someone could look at it and kind of understand what you've done. So the question is, it says a force of 1.5 newtons is applied to a spring, and the spring's extension is 0.25 meters. Calculate the spring constant. Notice in this question, they have given us the extension, so we don't have to work that out. They've also made it really easy, or I've made it really easy, in the fact that you don't have to convert your units. So they've given it in meters. If they've given it in a different unit, maybe centimeters, you might need to do some conversions here. So just be aware of that too. Always check your units. So all we need to do is write out the equation. It's asking us to calculate the spring constant, so we must rearrange it. So we have K, which is the spring constant, equals the force divided by the extension, which is 1.5 divided by 0.25, and we get an answer of 6 newtons per meter. And we've underlined it so it's nice and clear. So here's a question for you. It says the force, or a force of 2.3 newtons is applied to a spring. The spring's extension is 0.5 meters. Calculate the spring constant. So the exact same method you'll need to use. I'll leave the answer in the description box below. Have a go. It'd be great to see what you get. So what actually is the spring constant K? Well, the spring constant is a measure of the stiffness of a spring up to its limit of proportionality. And this will depend on each type of spring. Some springs are much more stiff than others. But essentially, what does that mean? Limit of proportionality. Well, the point where Hooke's law no longer applies in an elastic object. That's essentially what it means. So Hooke's law essentially tells us, looking at the equation, that if we increase the force, we can increase the extension. So the force and extension are directly proportional to each other. However, the limit of proportionality, there is a limit to how much proportionality that can be. So if we increase the force to a certain point, the extension will only reach to a certain point, and there comes a point where that elastic deformation, it actually becomes inelastic. The deformation is permanent, and that's what we mean by this limit of proportionality. So the object is essentially permanently deformed. So if you had, for example, a balloon, if we blow up a balloon, it's very elastic, it can stretch and extend in its size. But there comes a point, if you extend the size of the balloon far too much and you apply more of a force, actually, once you let go of the balloon and you release the force, the pressure that's going on in there, you actually will notice that the balloon starts to be permanently deformed. If it no longer looks like it originally did, it's actually much more wrinkly and saggy, which is essentially what happens in other objects as well. So this is what we mean by the limit of proportionality, and let me show you what that looks like graphically here. So here's the graph that we could use to interpret the limit of proportionality, and we could actually use this graph to calculate K, or the spring constant of a given spring. So for example, we've got some data and we've plotted it. It's quite a rough graph, I will say. Remember, in science, you can always have a curved line of best fit. It doesn't have to be a line going through the origin with a ruler. Sometimes it can be a curve. So go with the flow of your data is what I would say. I will do a whole video on graphs at some point, because I know that this is quite a tricky topic for some students. So if you would like me to make a video on graphs, do let me know. Give this video a thumbs up and I will make that for you. But essentially, all you need to do in this practical, you are measuring the extension as you apply more of a force to the spring. And as you can see, over adding more and more force, you can see that the extension starts to increase. So that proportionality is there. You can even see it's a linear line. So that relationship is linear, meaning it's directly proportional to one another. However, there comes a point when you add too much force and there starts to be deformation, which is actually where the limit of proportionality occurs. Hooke's law is no longer applied here. Remember, Hooke's law is when the force and extension are directly proportional to another. And as you can see on the graph, when it starts to curve and go away from that linear relationship, that linear line, that's when you know there's deformation, because the spring will no longer go back to its original point. And that's kind of the ultimate idea for this practical. And that's it from me today. A bit of a quick piece of revision for you. I hope you enjoyed it. I've been the GCSE science teacher and you have been curious. If you did enjoy the video, please do give it a big thumbs up, share this with someone else, and also subscribe. It'd be great to have you here. So don't forget to do that. You can also check out other videos of mine for biology, chemistry and physics GCSE here on my channel on YouTube. I'll link some for you at the end of this one. And also do feel free to check out my Instagram and TikTok. Everything is always at the GCSE Science Teacher. Have a great day and I will catch you in the next one.